Thanks so much for joining us. I'm Rebecca Cummings, the Digital Matters Librarian, and I'm pleased to welcome you today to our workshop, Expecto Datum, How to Analyze Harry Potter Using Digital Humanities Methodologies. Our presenter today is Max Schleicher, one of our Fall 2020 Digital Matters Graduate Student Fellows. Max is a PhD student in English, where he studies poetry and creative writing, and the places that the digital and poetic intersect. During his Digital Matters Fellowship, he will be using natural language processing to study poetry book blurbs as a way to gauge what readers expect from contemporary poetry and to provide a window into the sociology of contemporary poetry. If you want to hear more about the work of our Fall 2020 faculty and graduate student fellows, I encourage you to attend our Fall 2020 research talks at the end of this month on November 30th from 1 to 2:30 p.m., which of course will be happening virtually this semester. I'm going to ask you to please mute your mics during Max's presentation, and feel free to add your questions to the chat box so we can answer them during Q&A. Now, without further ado, I'm going to turn the microphone over to Max.
Great, thanks Rebecca, and thanks everyone for showing up. Let me get my screen share set up here. All right, well, let's get rolling. I will, as Rebecca was saying, feel free to drop questions in the box as we go along, and I'll drop in some information at the end of the presentation to give you guys some more resources and that sort of thing. But let's kick it off. So today we're going to be talking about analyzing Harry Potter text using some digital humanities methodologies. And this presentation is totally beginner friendly and really oriented around getting you oriented in using these kind of methodologies, which you might not be familiar with. So to begin with, let's talk about what we're going to be doing broadly speaking, which is text mining. You probably heard this word, this phrase bandied about. You know, it's used in a lot of different contexts, from business to research, and we're going to be talking about it in terms of a literary studies application of text mining. So text mining, broadly speaking, is turning text into data. And so for us, that means we're going to be taking like a text file and then doing some analysis on it to return a few different kinds of things like word frequency, sentiment analysis, and potentially topic modeling, but we don't have a ton of time to go into that today. And so to do this, you really don't need too much, anything sort of special. You need a couple different tools. The first, I'm doing this text analysis in a programming language called R. So you'll probably need something like RStudio to do that. You'll be typing code in that, and it will run the code for you and produce the data visualizations that you write in that code. RStudio is totally free. To get that to work on a Mac, you'll need something called Xcode, which basically is just an under the hood utility to allow you to execute code that you program on your Mac. These two things are totally free, but they require some resources. They are each a few gigs of space. So you may need to clear up space to do that, to have those things installed on your computer. So you need those. Again, they're free. There's lots of resources to learn how to do this stuff. And the last thing you'll need is this, which is not a broomstick, but rather you'll need the patience of Madam Hooch trying to teach Neville Longbottom how to fly. Because when you're working on text stuff, text doesn't necessarily always lend itself to data. And if you're analyzing a text file of Harry Potter, the file you're working on may be a file that was like imported from an ebook, which means that it has weird formatting issues that got inherited from an ebook, and you'll need to clean that up. So when you start doing this kind of work, so much of the time you'll spend is really just kind of cleaning things up and making everything formatted in a certain way that you can't actually do the analysis. So it takes a lot of trial and error. It takes a lot of patience, like teaching first years to fly or something like that. But let's get started. So to begin with, we'll talk about some basic terminology. So fortunately for people who like Harry Potter puns, the term that we have for the group of text that we're working on is a corpus. So I'll call this Levy corpus here. And a corpus is just our group of unstructured text. And so in my analysis, that's going to be the 7 different Harry Potter text files. And these are your raw materials, just the actual text of all of the books. So to work with these texts, we're going to Library corpus here. We need to process each of these documents and clean them up in some way or enrich them with data. So if you just look at the open text file here, hp1.txt, you look at this and think like, okay, what kind of data could we add or extract to this text? So some real basic things, we can track what book this is. So the title of the document, HP1. We can track by chapter. All the text that follows chapter 1 can get coded as being in chapter 1. And then we can track things like this first line of the first chapter, Mr. and Mrs. Dursley of number 4 Privet Drive. We're proud to say we can encode that with a piece of information that says that occurs on the first line or a certain line number of every book. So to do that little bit of enriching of that text, we can write some code. So this code, again, is about maybe 12 lines or so, not super complicated, and that will enrich this book with all of that data that we looked at before. So I'm just going to talk through some of this. I know that like looking at someone's code is not particularly interesting, but just to give you an idea, especially because like I mentioned, I want this to be pretty open to beginners, to give an idea of like how you would begin thinking about this kind of stuff if you're totally new to it. So you can see that basically what you'll do is you'll write a program that tells to look in a particular directory. In this case, my directory for digital matters with my Harry Potter texts. Scan that document. You see that second line there, scan HP1 text. And then it's going to break it apart into separate lines. So there's a part there that says separation equals /n, which is just that /n is an invisible character in a text file that tells it where the line ends and the next one begins. And so it just basically searches for that and then breaks every line every time that there's a line break. We're going to turn that into a data frame that's going to help us do this, make sure it's coded as a character and not numbers. Then we're going to make sure that we can track that Mr. and Mrs. Dursley live in number 4 Privet Drive occurred on the first line. So we're going to write a little bit of code to do that. And then the third section here, we're going to add a column for chapter. And this is kind of interesting, a piece of code here that's going to search, as you can see, kind of halfway through that last line, that string detect, str detect. It's going to search for any time that there's the word chapter followed by a number, and it's going to extract the number that follows that chapter, and that's going to encode all of the lines that come after that until the next chapter with that particular chapter number. And then lastly, it's going to break all of those lines into individual words. So I know it's, like I said, not super exciting to look at what this code looks like, but it's about 13 lines, and it gives you something like this. You'll see that we were able to enrich every word that from this text so that we can see that Mr. and Mrs. Dursley of number 4 Privet Drive were proud to say that they, etc. We can see that occurs on the 5th line of the book in chapter 1, and that we've got all that data for every single word of the entire corpus, all 77,915 words. So you can see how we've turned these couple things that we wanted to highlight from the actual text file now into a working database, a working table of all of the individual words. This doesn't seem like a massive transformation, but it allows us to do some really interesting things. So let's begin with something super fun. So I've got all these words in my table, and what do I want to do with them? Well, one thing you can think about is like, how do you tailor your analysis to the text you're working on? Is there something in particular with Harry Potter that you want to dig into? And so the first thing that came to mind was spells. And I thought, okay, well, a spell is always spoken. So like Hermione is saying on oaths, spell the appears in the text is a sign that is an instance where that spell is actually being cast. As the note says, we're obviously going to be ignoring the non-verbal spells. That's for advanced 6th years and stuff like that. So if we track every time that Wingardium Leviosa appears in the text, we can kind of visualize the distribution of spells. We can visualize when they appear in the course of the text. So let's take a look at what that looks like. So here I've got these spells broken down into the different types of spells: transfiguration, charm, curses, and looked at how frequently when they appear in the course of the text. And so you can see that in general, you start to see more spells appear in the later books. And so like this, the line number at the bottom represents the line numbers of all of the books consecutively. So it's not just the first book, but the first book through the seventh book. So you can see that in the sixth and seventh book, there are more spells, especially more sort of curses, as well as combative spells like counter spells and that kind of thing. But we also see that in general, there's much more charms being cast than the other spells. Maybe this isn't particularly revelatory, but it's a fun kind of way to start exploring some of this data. We can also visualize this distribution in terms of just the total volume of spells cast. So we can look and see in the course of the 7 books which spells are most common and how we break that down by spell type. So we see here, one thing that's interesting, I think, is that there aren't that many. There are many different spells cast, but most of the spells cast are things like the Killing Curse, the Body Bind Curse, Cruciatus, Patronus, Wand Lightning, etc. So a few of the spells make up a large number of the total spells being cast. Again, this is just kind of a fun way to explore and start thinking about what data we can extract from the text itself. So, okay, we've gotten started. We just did something fun. Let's talk about something maybe a little bit more advanced, sentiment analysis. So to do sentiment analysis, we want to be more like Hermione and less like Ron and Harry. What do I mean here? Let's go back to the text. Hermione here is saying, "Don't you understand how Cho's feeling at the moment?" Hermione asked. "No," said Ron and Harry together. Hermione sighed and laid down her quill. "Well, obviously she's feeling very sad because Cedric's dying. Then I expect she's feeling confused because she liked Cedric and now she likes Harry, and she can't work out who she likes best. Then she'll be feeling guilty, thinking it's an insult to Cedric's memory to be kissing Harry at all," et cetera, et cetera, et cetera. That's one of my favorite moments in the book. Anyway, so what Hermione is doing here is she's obviously reading the sort of emotional situation between Harry and Cho. So sentiment analysis does something like that. Sentiment analysis, we're going to take all the words in the books, and then we're going to run it through a database to figure out which of those books are sort of positively emotionally or which of them are negative emotionally. And then we're going to have an output that has those words marked as positive or negative, as well as words that didn't get marked by that database. So for us, we're not going to be using Hermione to read the emotional tenor of the books. We'll use a database that Microsoft Bing has publicly available, and that will run all of that, the database of words that we've got through there. So that looks like something like this. It's really simple. Basically one line of code. We just join the database that we had before with this database from Bing, and then that enriches our data now with another column that tells us whether the words are likely to be positive or negative. So we can see here, looking at the beginning part of the book again, words like proud, perfectly, thank are positive, whereas strange, mysterious, nonsense are negative. So if we actually look at a passage of the text, this is kind of what the data is telling us here. Again, from the first chapter, we see that in this section about the Dursleys, that the Bing database is telling us that the words dull, cloudy, strange, mysterious, boring, mist, and tantrum are negative, whereas work, happily, flutter are positive. So what we can do now is actually score sentiment for a particular passage of the book like this. And what we'll do is we'll just add up the negative and positives, subtract the negatives from the positives, and end up with a net score. So this process would score these 3 paragraphs as having a -3 sentiment score because of the 4 more negative words than positive words. As you can see, it's not entirely exact. It's missing some words that we might think of as particularly positive or negative, like kiss. But basically, since we're going to be doing this over the entire course of the book, we're going to assume that those kind of things that it misses or gets wrong are going to get washed out, and that it'll be mostly accurate. So we can do this instead of just doing this on 3 paragraphs. We can do this chapter by chapter in the book and see what the sort of emotional ebb and flow of the book looks like. So we do this for book 1, and we get this visualization of how the sentiment fluctuates in the course of the book. So as you can see, the first 4 chapters of the book are negative. You know the story. The Dursleys are keeping Harry in the cabinet under the stairs. They're not letting him have his letter from Hogwarts. And then eventually Hagrid beats down the door at their cottage by the sea. And in chapter 5, as you can see where there's this green spike, he tells Harry, "Harry, you're a wizard." And then they go to Diagon Alley. And so you can see this sort of uptick that we know narratively from the book matches with the sort of sentiment data, roughly speaking. But looking at this this chart, we see that maybe it's a little bit too broad, because we see that like the last chapters are all negative, which is kind of true, but there's definitely some uptick at the end of the book. So we're zoomed out too far to get enough articulation. So we can, instead of looking at this chapter by chapter, group instead look at groups that are every sort of 80 lines of text, which you might think about every 3 pages of text. And that gives us a little bit more detail to look at like the emotional ebb and flow of the books. And so that tells us that the sort of additional detail here tells us that, again, the end of the books, there's actually some positive going on. And then we can see that in the middle books, it's not all negative, but there's sort of up and down parts in the middle of the book. So that's kind of like, if we look around line 50 and to 75, that's sort of like you win some Quidditch games, you lose some Quidditch games parts of the books. And this also raises some interesting questions about the sort of narrative structure of Harry Potter. You might begin to ask, like, because the books are all structured in the same way, starting in Little Whinging at Privet Drive, going back to Hogwarts, having an emotional lift, having some conflicts with some good things at Hogwarts during the school year, then having the major conflict, then saving the day and getting a pat on the back and a wink from Dumbledore before ultimately going back to Privet Drive. There's such a similar arc in the story, in the emotional story of the books, that maybe there's some some repetition between the books in this sort of like emotional valence over time. So we've looked at it kind of zoomed in away, but let's zoom out even further and for what it's worth, see what it looks like if we just kind of look at the general ebb and flow of it in the broadest sense. And so we kind of do like a moving average or something like that. And we just get a general shape of how the emotion rises and falls. And so this will be maybe helpful for us to compare the different books to each other. So if we do that, and again, we're just kind of doing exploratory analysis. We're saying, like, okay, is there anything here between these 7 books that prompts us to have a follow-up question? And so I look at this, and one of the things that jumps out to me is I think, oh, it's interesting that there's kind of this well, a trough of negative emotion during the climax. And again, maybe that makes sense. Aristotelian sort of rising action theory of how things work, that, there's climax, but maybe that there's my follow-up question would be like, maybe there's a particularly negatively valenced emotional part of the climax in Harry Potter, because at the climax, at every major conflict at the end of the book, there's always some recurrence of, in some way, that Harry has to confront the death of his parents through his confrontation with Voldemort or one of Voldemort's minions or something like that. So you can think about like, oh, again, maybe there's something to the emotional structure of these books that we can kind of nuance from looking at these data visualizations. And the last one we'll look at for sentiment analysis is basically putting all these books back to back to back and looking at the general flow and seeing if there's anything that jumps out with what we see in the negative and positive emotions of the books. So for me, there's a lot you can sort of dig into, but let's just look for like something that stands out really obvious to me. We see the lowest point in the books is towards the end of book 6. And again, if you've read the books, that should be no surprise. We're probably looking at Dumbledore's death here at the end of book 6. So while these might not be entirely precise, they do give us sort of directional and good like visualizations and good promptings to sort of think a little bit deeper about what emotionally might be happening in the books at scale. So sorry, I lied. One more. We'll look at this is just overlaid the 7 books, and so give a chance to compare them in a different way with this visualization. And what jumps out to me that I find kind of interesting is that the first 3 books all have happier endings than the last 4. So that's kind of an interesting thing to think about. And maybe it's not precise enough to draw that conclusion from sentiment analysis, but nonetheless, it's an interesting starting point for a follow-up question. So we can ask, what do we learn from the sentiment analysis? But as I was hinting at just then, it's probably better to think about not deriving a meaning necessarily from sentiment analysis, because it may have some, enough variance in the results that you don't want to derive any sort of like hard fact from it, but rather you want to ask like a follow-up question. So we might think, okay, how does Harry Potter's sentiment compare to other children's books, the flow of the sentiment? So you could do the same sort of analysis, but then overlay the Narnia books, the Golden Compass books, you name it, and sort of get a sense of maybe does that sort of, as I was talking about, that well or that trough in the climax, is that something particular to the sort of current YA Harry Potter mood that we have about sort of like emotionalism of these books? Maybe we can kind of compare that and test that out by looking at other books as well. Another follow-up question we might have is that, as I was just alluding to, the first 3 books have happier endings than the last 4. Maybe it's interesting to think about the last 4 books as tragic comedies, that there's maybe a shift in the tone of the sequence of 7 books, whereas the first 3 are sort of more traditional comedies where everything works out, whereas in the last 4 are something like tragic comedies, something worth exploring in that way. So the last thing we're going to talk about is word frequency, which doesn't sound particularly interesting, but it is really interesting from a theoretical perspective. So what are word frequencies? How do they work? What can they tell us? So what we're basically going to look at is this sort of probabilistic distribution of the words in these Harry Potter books, like how many appearances are there for the most frequent words, versus how many appearances are there for the least frequent words. And doing a visualization like that gets something like this. And you can see this sort of like really fairly regular probabilistic distribution where you have a ton of the most frequent words appearing, and then the least frequent words become this like long tail distribution at the end. And he's like, oh, that's interesting. This looks very much like some kind of probability. And what's really interesting about this is that those are the 7 Harry Potter books. These are 6 Jane Austen novels. Same distribution, same structure. The distribution is basically taking place. Things are really interesting. We overlay the 7 Harry Potter books on top of each other, and we get this. This is another way of visualizing it. They look really, really similar. So what's going on here? Well, what's going on here is that there's this linguistic principle called Zap's law, which says that there's this inverse relationship between word frequency and the rank of the word in a frequency distribution table for those texts, which is kind of a mouthful, but basically it means that all books all documents tend to work on the same sort of linguistic principle surrounding the frequency of the words that they use. And why is that interesting? Well, if you just imagine we look at the 100th ranked word, so if you look down at the bottom where it says 100 and just go up, we could pick that 100th ranked word and look at what the 100th ranked word is for each of the 7 different texts and see what it is. And so for one book, it might be Quidditch. For another book, it might be something else. And that will allow us to kind of compare which words are relatively more or less important to the other books. And so again, I mentioned that this is kind of theoretically grounding us. And what this linguistic law tells us is that like there's actually a kind of mathematical language for comparing documents across different documents. So using this principle, we can basically find out which words are the most relevant, most salient, the most likely to distinguish one book from another. And that's what we get here. This is what's called a term frequency, inverse document frequency, rolls off the tongue, way of analyzing these things. And so you'll see that these words are all kind of representing like which are, again, the most distinct for each book. And so we know, so if we see in book 1 that if you mention Quirrell or a troll, that's going to tell you that it's in book 1. So one way of thinking about this is if I just said, I'm going to read you a sentence from Harry Potter, and that sentence contains the word crumb, you're going to tell me there's a good chance that's in book 4. Or I tell you it has Xenophilius Lovegood, you might tell me it's probably book 7. It's a good chance it's book 7. And that's what this is telling, this kind of visualization is telling us. That may not seem like the most, again, like, mind-blowing thing, but it allows us to do a lot of really cool analyses and comparisons. So for example, if I were to take a bunch of election coverage from Fox News, NPR, New York Times, et cetera, and do this kind of analysis, what we would find is like, what are the words that distinguish something as being from Fox News versus something that's being in the New York Times? And obviously this is going to tell us it's not going to be words like election or the names of the candidates or something like that. There would be something under the surface that tells us that is more likely to reveal sort of like a shibboleth of one that is from one source versus another. So this becomes a foundation for a lot of comparative studies between texts, which is really interesting. So just to wrap things up, remember to keep putting questions in the box as you have them. We learned that you can enrich text just adding a few basic pieces of data where a word appears in a chapter, in a line, that kind of thing. And that allows you to do a whole lot of stuff. That you can use text mining, not necessarily to find an answer, but it's a really good exploratory place. You can start to think about like, oh, what did I see here that leads me to ask a follow-up question, and then perhaps figure out a more exact way to research that question and what other context you need to bring in. That means if you need to bring in other YA novels or other children's books, you can do that kind of thing to a follow-up analysis. And lastly, that there is a theoretical grounding that connects different texts because of the way the probability of distribution of words in text is very similar. You have a theoretical basis for comparing word frequencies, and that will show you like the salient differences between books. So that's all I have in terms of the presentation. We'll obviously switch to questions here in a second, and I am going to drop into the chat box some resources that'll help you guys. But if you have any questions, you can email me or reach out to Digital Matters after the fact. So thanks very much.
Great. Thank you so much, Max. Okay, we just stopped screen sharing. And so I encourage you to either give Max a hand virtually if you have your little clapping emoji, or just in person, but I thought that was terrific. We have lots of questions that are, oh, I love it. Great, thanks everyone. We have some questions, Max, that have already come up in the chat box. The first was actually from me. I feel like a little bit of a cheater doing that, but I am curious though about, the act of writing code for text mining, because I know that some people write code from scratch, others repurpose code that they found. I'm curious about your own experience. Like, did you write your own code? Did you use someone else's? And if you repurposed, I mean, what level of coding knowledge do you need to have in order to repurpose code?
Yeah, I think you don't need a ton of knowledge to repurpose code. And the first link that I shared is for a text mining textbook that's online, and it's super simple. And so I repurposed a lot of stuff from that for this presentation because I think they just explain it pretty well. And so like I think that like I would say that if you're starting doing this and you just set aside a Sunday, you could do a lot of the stuff that I did today over the course of like 8 hours of getting oriented and learning it. There's a lot of good resources, and it isn't that hard. And like I was saying, I know it's not especially interesting to look at some code that I put out, but most of what I wanted to explain or show is that like by writing about 13 lines of code, you can at least have a product that is an actual working table that then you can apply some analysis to. So the next step of going from that to doing a visualization does take a lot of trial and error, but it isn't as big of a technical hurdle as people would probably anticipate.
Thank you. The next question in the chat box is from Chris Lacuse, who says, totally noob question, but can you define unnest? In what sense are words in a text file unnested?
Yeah, thanks, Chris. I did just sort of jump over that. So basically, unnesting is both like the literal, in this sense, is like the term that this particular text analysis package in our tidy text, which is what I was using, uses. And basically what that means, if you think about that line of words, Mr. and Mrs. Dursley lived at number 4 Privet Drive, it takes that line and it unnests it. So it separates each word into its own line. And when it does that, it does a couple things. I believe that it also makes it so that you can re-nest it later on if you want to, for whatever reason. The sort of like behind the scenes that there's enough tracking to do so, but it unnests it. And then what it does is it keeps whatever other data is in those columns, like the chapter, the line number, the set, whatever else you want to add to it, keeps that for each of those ones below. And so it's just a way of separating the words while also keeping the other data that was connected to the line as a whole, and then potentially being able to re-nest it sometimes too.
And Chris also pointed to a resource, which is in the chat box. So he said that there's some very interesting work like this that's been done across the massive Google Ngram in a PLOS paper. So if anyone's looking for that, that's in the chat box. I had another question. This is a topic that interests me a lot, and I'd wondered, like, when you're doing sentiment analysis, and it's a small enough corpus, you probably could do some manual recoding of the word. So, like, let's say you're reading it, and you can see that, like, the word mysterious is not negative in that context, so that it's a positive. Do you have any ability to recode individual words for greater accuracy throughout the text?
Yeah, and it would be pretty simple. So if you can imagine back to like where I had that basically just joined my text with this database from Bing, you could just kind of put an intermediary step where you would say join the Bing with its own custom database that you have, where you basically have words like mysterious is this or whatever. And so you could you could just add your own words to it if you wanted to add them, or if you wanted to, in a sense, delete them, you could just basically duplicate the Bing database or whatever, and match it, and then remove those ones and swap them with your own second like set that you are wanting to replace them with. So sometimes this happens, I was looking at this example in that textbook that I mentioned, where it's from the Jane Austen novels, and there's, like it codes miss as a negative word, but they're always like, Miss Elizabeth, Miss, and so it's not actually used in the same way. So yeah, so sometimes you'll just exclude things like that are red herrings that are going to mislead you or whatever. And I cut out some intermediary steps where you might just look at what the most common ones are and look to see if there are any outliers there that might be messing things up, and that you might want to either recode or just omit from the analysis.
Thank you. So here's a question from Logic Club. How do you determine which words to discard from word frequency analysis?
It depends on what like your end goal is. And so like it's really a really nuanced question. So if you can use word frequency to determine authorship, and so people actually did this with J.K. Rowling because she published that detective novel under a false name or under pseudonym, and so people took that and that text and compared it to the Harry Potter text and found like a really strong author similarity. But to do that, actually, you don't discard any words. So even words like the, in, is, that we think are like just the most basic dumb words, are actually really revelatory of individual idiosyncratic style. So sometimes words like that are sort of like the fingerprint. And so for an analysis like that around stylistics, you keep those words in. For an analysis that might be around other kinds of things like content, topics, you'll probably end up removing those to find things that are kind of like the more meat and potatoes. When you do analysis on like fiction, the names of characters get repeated a lot, and so sometimes you might omit that if you feel like that's just like pointing to too much obvious stuff. And so it's a matter of kind of like tuning your analysis based on what you need, and it's different for different circumstances.
Great, thank you. We have a question from David Rowe. What are some good resources for finding clean humanities data and or arts data sets?
Yeah, there are a ton of good ones, and I'd recommend folks to drop some more in it because I'm sure I won't remember them. One of the nice things about working in like in R, for example, is there's a lot of data sets that are publicly available. So like the Tidy Text, which is the framework that I was using, they've got like Jane Austen or the Bronte sisters or a bunch of other things that are pre-programmed. And I think if you use like a Gutenberg function, you can actually get any book from Gutenberg immediately imported. And you basically just say like, you just write a line of code that says something like Gutenberg parentheses and then the number of the book on Gutenberg, and it will import that data set. There's also the Hathi Trust, HATHI Trust has a lot of books publicly available. And, you can find a lot of things just kind of by Googling, but those are places where I might look initially, but there's a lot of other good stuff out there.
And this was funny from Yamna. She said that the Logic Club was actually her.
I'm not surprised, Yamna.
Name her. I was hoping we actually had a whole club of like kids who learn logic watching this right now, but
yeah, it was quite intimidating to like, I don't know, I'm gonna answer Logic Club. They're gonna analyze my code too closely.
So those are the questions we have in the chat box. If someone wants to just either write or verbalize their question, feel free to. We still have about 10 minutes, so time if we have additional questions.
Max, would you, I don't mean to put you on the spot, but for those of us who are unfamiliar with RStudio and how you run the code, would you mind like taking us through a quick overview of the interface?
Sure. I could potentially load it up and do that really quickly. Um, yeah. Whenever I give a presentation, I always quit everything and just like restart my computer so there's nothing going on in the background. It's just like paranoia. And so give me a second to restart R. Yeah, if you've never, and I know that David, you've mentioned that there's like some ways of spoofing R online that that you can do through like some web-based analysis. So Michelle asked me like what data analysis surprised you the most? That's a good question. I think that like thinking about just looking at the sentiment analysis and thinking about how the book's structure, I thought might lend itself to a particular emotional, like repeated emotional flow in the books. I thought was really interesting because like the literal like geography of Harry starting in Little Whinging, returning in Little Whinging, going back to Hogwarts, always having a sort of like uptick emotion, like coming back home to Hogwarts. And so like I was thinking about just how that from a narrative and emotional affective perspective, like how what that is, because it's this sort of cyclical structure. And I don't have a good answer for like what that means next, but I found that really intriguing. That sort of like, because the books always enact this sort of like going home to Hogwarts, and there's always like an excitement at returning to Hogwarts. And so in some ways, there's always a way that which the later books enact what happens in the first book, which is kind of like the emotional peak when Harry finds out that he's a wizard. And so that thinking about that is what's excited me the most, though I don't necessarily have like a result from that yet. But I think that's a really interesting way to start thinking about what the books are doing. All right, so my RStudio is loaded. Maybe I'll just answer Yamna's question about context. So I didn't account for context. There are like complicated ways of doing that. So the style of analysis I did is just looking at individual words separated from context, besides like the numerical context of the number of the line or the chapter that they appear in. There are more like complicated analyses of thinking about words in vectors, or like either in a group of words like bigrams, or like how they appear in a sentence and then deriving context from that. So I haven't written any code to do this, but I've worked with data that will do things like it'll extract a keyword from a sentence, and then it will enrich that keyword with a sentiment probability based on the words that surround it, both just in terms of like their proximity to the word, but also surround it grammatically. So if it's like Harry was sad, it'll understand that like there will be like a sort of structural analysis of the sentence that understands that sad is a complement that then refers back to Harry as the nominative of the sentence, and then uses that to enrich the probability of sentiments. So you don't just get a sentiment score, but you get a probability of how likely it is to be positive or negative based on the context of that. So there are more complicated ways of doing that. But again, I kept it pretty simple, and I'm not sure I've got the chops to quite do that. But let's open up RStudio here real quickly. Okay, so you guys should be able to see this, but this is basically what RStudio looks like. And you can see that there's, let me just clean up everything that I have, all these old objects. And so there's a terminal down here where you can kind of code freestyle if you want, or you can use this, which is an editor to actually run code. So when you are doing some coding like this, you'll basically load the packages you want to use, which I'm doing now. So I'm using tidy text to do this, and dplyr to kind of reorient the things that are pulled. And then I'll just do something like, this was the first bit of code that we looked at. You'll see I just selected, do command enter, and immediately, as quick as that was, I now have a database of a tiny database of Harry Potter words, which is like what we looked at before. So you see like how quickly you're able to actually perform a lot of these commands. So let me just do one that also does a visualization. So if I do one that does a visualization here, you'll see the visualization pops up in the lower right, and then I can sort of zoom in and take a look at how it all works. So it's a nice, clean way of keeping track of everything. You've got the full code that you're writing here. You sort of like the kind of live feed at the bottom of as code is being processed. And then you have like the environment where you have the actual data objects that you create, the different tables that you're looking at, and any visualizations below. And it also has some nice features, just like it has like a help feature. So if I'm like, oh, I'm working on trying to do a particular data visualization using columns, I'm going to search for that function here. And then it's like, oh, here's all the help for how to use a bar chart, how I need to code a bar chart to get it to work right. So it's pretty robust, and it can be a little confusing if you've never done any sort of coding, how to get all this stuff working. But spending a few hours, you'll pick up a lot of stuff pretty quickly.
Max, we have 3 more questions in the chat box right now. One is from Chris Lacuse. Would we expect that the most common words in Harry Potter and Jane Austen would be English function words like the, and then the 2 distributions diversify as we get closer to the lower frequency words?
Yeah, totally. And there's that's definitely what it's going to be like, but it'll diversify pretty quickly, because character names are going to be one of the most common ones too. And one of the kind of like interesting things about this kind of analysis is if you do something like a topic modeling, you sort of look for a sweet spot where like the rare words, yeah, they're all going to be different, but they're also not, they're going to be so rare that they don't necessarily actually tell you anything significant about the book as a whole. Like, J.K. Rowling uses this one word once. That doesn't mean it's like especially relevant, right? So like when you do something like topic modeling, you're kind of finding somewhere in the middle where the words are frequent enough to be relevant in the sense that they're like definitive of that book or that text as a whole, but they're also different from the other books. And so those are the words that stand out. And that's kind of like what that ladder visualization I was showing you guys of like how grip hook is in book 1 and book 7. And so that will tell you that's likely book 1 or book 7 or something like that. But doing that, you can do it in sort of a fun way across lots of text to kind of visualize what are sort of like topical words, what are distinguishing words between texts.
David's question is faster than mine, so I'm going to put his first. Are you able to share your code and text files with us so that we can run these analyses ourselves?
Totally. I don't have a handout quite yet, but if people want to drop their email addresses, I'll share some stuff then. As I dropped in before, some really helpful sources that just to get up and running. Again, like you can spend some hours on a weekend working through this, but I'll send out some code afterwards. The second question about files and stuff like that, I'm not sharing any Harry Potter text publicly with you guys, which is not because it's illegal, but because of copyright laws, which is what Rebecca asked about. It's great for us to use these kind of things for research, but we just don't want to post them publicly. So fair use protects us using these kind of files as research, but we just don't want to have them hanging around on a website for people who might use them not for research. So happy to share those those files, as well as like some documents with code through emails after this.
Okay. And then just to get to the second part of my copyright question, how were you able to get those Harry Potter texts in a plain text file because of copyright?
Yeah, I found other people who had done some research on Harry Potter and was able to get it that way.
I see we are at time right now, so I'm going to go ahead and say thank you one more time to our presenter, Max. It was a great presentation. And thank you to everyone who attended. If you have additional questions, please feel free to reach out to us. Again, we have our research talks at the end of this month on November 30th. Is that right, David? I think it is November 30th, but either way, we'll be posting, of course, on our Digital Matters listserv and Flash and all the places that we always post. So thanks so much, everyone, and we will see you soon. Stay well.